But when it comes to this persistence thing, I have to ask myself if all the use cases of sculpt deformers for this project demand the level of persistence that the sculpt deformer offers when used directly. At the moment, I have 4 corrective deformations that I want to tackle with sculpt deformers: the finger tendons and knuckles, the volume preservation of the glutes and the hip area, the abdominal muscles impression on the stomach, and the impression of the rib cage on inhalation. Of these 4, there are only 2 that might require a super persistent deformer: the glutes and hip preservation, and the rib cage, because there are so many joints and rig features impacting that region. If the torso is contorted into an extreme pose, which is often required for animation, I need an overwhelming persistent deformer to preserve the impression of the rib cage. Now, when it comes to the fingers, weirdly enough, there is not that much complexity in finger and hand poses. To pose the fingers, animators usually rely on 2 degrees of rotation. And as far as the palm is concerned, the only joint that simulates movement over there is the cup joint, which is not going to present that much of a problem to the sculpt deformers responsible for my finger tendons and knuckle impressions. So just like with the cluster options, I reserve the option of utilizing both of these sculpt deformer methods to create my corrective sculpt deformers. So, after summarizing all of this information, I've come up with a computational expense grading tier that gives me an idea of what all these options are going to cost me in performance. This Excel document showcases the options I have, and right underneath them, I have categorized all the corrective deformations I want to do for this project. As previously stated, the cheapest solutions are the clusters, with the cluster being piped through an already established traditional intermediary blend shape being the cheapest. Next, least expensive, is an advanced skeleton cluster control, and that is only because it comes with a control and also because it will be processing directly on the skin mesh with a lot of other deformers that the skin mesh has to evaluate. The first question I'm asking myself with each corrective deformation is if it is simple enough to resolve with a cluster. Because as inexpensive and fast as clusters are, they don't offer that much complexity in deformation. They can be weight painted just like skin joints, but they offer slightly less complex deformations than skin joints. In instances like the one highlighted on the screen, where a corrective deformation is under 2 to 3 categories, it means that I am undecided about which of the solutions to settle with. So I place that corrective deformation on all 3 until I can finalize what I want to use to resolve that PSD. I'm more than likely debating between complexity of the deformation and the computational expense, or in the case of the sculpt deformer, between persistence of the deformation and whether or not I want to overburden the rig by applying the sculpt deformer directly on the mesh. There are also some instances where I'm debating whether or not the sliding effect that Advanced Skeleton's custom soft mod control provides is going to be enough, or whether I should go with a more expensive sculpt deformer which simulates the most realistic looking sliding effects. Let's take a quick look at a comparison of the sliding effects that these 2 deformers provide. Alright, so in this scene, I'm using the Napoleon character from Advanced Skeleton, and I want to compare the sliding effects of a sculpt deformer to the sliding effects of a Advanced Skeleton soft mod control. So in here, I've created a sculpt deformer, and this sculpt deformer has been positioned in a way that it impacts the neck. So if I go to the sculpt deformer and turn on the envelope, and I set the envelope to 1, you should see it's impacting everything in that region. Let me hit 5 so you can see what it's doing. Right? And this is because of the maximum displacement set. And when I select the sculpt deformer, I'm able to simulate sliding effects by just moving it up and down. So this is, in this case, it would be a simulation of swallowing of sorts, but there are so many use cases of this. When you extend your elbow, your bicep slides down, and the same would apply for your cows. And in some instances, like if we were doing abdominals, we could have the abdominals sliding as the character crunches, and the same would apply for some sliding on the rib cage. If the character inhales or rotates the chest backward, we can have some slight sliding of the rib cage. So this is just a feature that you typically count on sculpt deformers to help you resolve. Now what I'm going to do is turn off the sculpt deformer and see if the soft mod can do a good job too. All right, and this time I'm going to try to keep the range smaller. Make sure I have the type of behavior that I want first. About there. And create the soft mod. All right, so now I should have something that's closer to what the sculpt deformer is doing. Just in that neck area. I'm going to hide it and just see this sliding effect that is provided with the additional locator that comes with it. So yeah, it's doing a great job. One of the things I thought would happen is that I thought it would stop impacting it past a certain point and just impact only the affected area, but it looks like it's the entire mesh. You can move this offsetter, this locator, anywhere, and based off of the geometry, it's doing some perfect sliding. So it's a much cheaper solution to use, and it's definitely something I can count on, especially if I'm looking for a simple predefined spherical shape to do the influencing. But if I want a more specific shape like a rib cage, I'm gonna have to sculpt that shape by myself and turn it into a sculpt deformer. But yeah, this is a short test just to compare the two deformers' sliding capabilities. Okay, so before we wrap up this corrective deformation plan review, I want to talk about two more things. The first is about a non-destructive workflow. When I use the term non-destructive corrective deformation, I'm specifically talking about any corrective deformation that does not in any way alter my main skinning. Under no circumstances do I want to go back to reassign weights unless it's for polishing purposes. Thankfully, all these methods listed for my corrective deformation are non-destructive, and the only one that could have potentially been destructive, Advanced Skeleton's joint-based skin control, is not, because I will be utilizing it with the multi-cluster skin feature that we got to take a look at while we were building and troubleshooting the head. I think I mentioned previously that it's also available for custom skin controls. The final thing I want to discuss is triggers. All these corrective deformations I'm about to work on are going to be triggered in one of 5 different ways. All Advanced Skeleton-based solutions will be triggered with Advanced Skeleton's driving system. I may use Maya's pose editor to trigger some of my corrective blend shapes, but the main triggering system I'm going to rely on for more straightforward corrective deformations is Maya's set-driven key system. There are instances where a corrective deformation has to be triggered by more than one driver. In a case like that, you will see me utilize more complex triggering solutions that mostly involve locators, distance nodes, math nodes, and other Maya utility nodes. When it's time for this type of work, we'll move into the node editor. There will also be a handful of corrective deformations which will require a control system to be triggered. In instances like this, I will try to go with an Advanced Skeleton solution which provides you with a control by default. But if not, I will go with a non-Advanced Skeleton solution and create my own control. All right, that's it for this corrective deformation plan review. In the next lesson, I will get started with the preparation work for the corrective deformation process.